Okay, so what if we wanted to rationalize the denominator? Of, let's say, 4 over the cube root of 2. Okay, so with this one, you can't just multiply both by square root. You have to actually have the cube root. Okay, so here you want to remember that the cube root of 2 times the cube root of 2, wrote 3 in the wrong spot, times the cube root of 2 is actually equal to 2. If you put those all under 1, it would be cube root of 2 to the third power, which is just 2. Okay, so that means if we have 4 over the cube root of 2, we'd have to multiply this by the cube root of 2 times the cube root of 2 in order to make the radical disappear. But whatever we do to the denominator, we have to do to the numerator. So it's cube root of 2 times cube root of 2 up here also. Okay, so in our numerator, we get 4 times cube root of 2 times cube root of 2 all over cube root of 2 times cube root always equals just 2. Okay, now these two we can just go ahead and combine them. So we'll end up with 4 times the cube root of 2 times 2 over 2, which turns out to be, if we go ahead and simplify those two, 4 divided by 2 is 2. Cube root of 2 times 2 is 4. So 2 cube root of 4. All right. Any questions on that one? Okay. So let's say if we wanted to simplify let's say square root of 50x over 2 square root of 2. And when they say simplify, they really just mean rationalize the denominator. Okay. Now with this one, there are a couple of ways you can do it, and probably the quickest little shortcut is to get anything that's not under a root symbol and factor it out. Okay, so if we have square root of 50x over 2 square root of 2, we can actually make that equal, if we factor that out to the front, that can just become 1/2 times square root of 50 over square root 50x, sorry about that, over square root of 2. Okay. Now if you wanted to, you can go through the factoring and everything else, but you don't have to for this one. All you have to do is remember, bless you, that square root of a over square root of b, we'll say nth root because it applies for all those. Nth root of a over nth root of b is equal to the nth root of a over b. So if we have a square root of 50x over square root of 2, we can make that equal square root of 50x over 2. Which kind of cuts down the work of reducing 50 to 25 times 2 and then the square root and then breaking it up. You can just do it in one swoop. Okay, so this ends up being 1/2 times 50 divided by 2 is 25. So square root of 25x. Okay, which we know since they're multiplying, you can just go ahead and separate them. So it's 1/2 times square root of 25 times square root of x. We know square root of 25 is 5. So that's 1/2 times 5 times square root of x. Or you can just make this 5 over 2. Or if you want to put the square root of x up top, you could have done that also. Close that up. All right. Any questions on that one? All right. Everyone's still writing. Nope. Look like everyone's done. Okay, so let's say if we wanted to simplify, five over cube root of 6n squared. Okay, and I'll let you start on that one. Bless you. Bless you. Alright, so for this one, you just want to remember, let's clean that up some. That the cube root of 6n squared times the cube root of 6n squared times the cube root of 6n squared, which is equal to 6n squared. You wind up getting 6n squared to the third power. They both cancel. Okay, so you have 5 over the cube root of 6n squared times cube root of 6n squared times the cube root of 6n squared. Got to do the same thing to the numerator, times the cube root of 6n squared times the cube root of 6n squared. Okay, so we know all of these multiplied would just give us 6n squared. Okay, so we have 5 times the cube root of 6n squared times the cube root of 6n squared. Okay, which we know we can go ahead and combine those two. So we have 5 times the cube root, let's move that up some, 6n squared times 6n squared over 6n squared, which gives us 36, well, 5 times cube root of 36 n to the 4th over 6n squared. Okay, now that n to the 4th, remember that can just be n to the 3rd times n to the 1st. So we can actually simplify that. Put that up a little bit. Okay, so that becomes 5 times the cube root of 36 times, once we go ahead and separate those, cube root of n to the 3rd times the cube root of n. So we just got the n to the 3rd times n and separate it. All over 6n squared. Okay. So we have our 5 times cube root of 36. Those two actually cancel each other out. So we have times n times cube root of n over 6n squared. Okay. You're like 99% done, only because this n and one of those n's will cancel out. Okay. So you end up with 5 cube root of 36 times cube root of n over 6n, which if you go ahead and just put those back under the same one, it's 5 times the cube root of 36n over 6n. All right, so any questions on that one? Okay. Okay, so that's assuming, just on those previous examples, you have just one term in your denominator. Now, if you have 2 terms in your denominator, the approach is a little bit different. Okay, so let's make sure anyone's view that up for a few more seconds. Oh, looks like everyone's done. Okay, so rationalizing the denominator with two terms in the denominator. Okay, so if you have two terms in the denominator and you want to get rid of any root values or radical symbols, rationalizing two terms in the denominator involves multiplying the numerator and denominator by the conjugate. Okay. And the conjugate is really just the same two terms, but you're switching the signs. So for example, let's say square root of 2 plus 1 and square root of 2 minus 1 are conjugates of each other. Okay, same thing with 3 minus square root of 2 and 3 plus square root of 2 are conjugates. Okay. Even if you had two root values, the two radical symbols, say square root of x minus square root of, let's say 4, that'll just become 2. Say square root of x minus square root of 5 and square root of x plus square root of 5 are conjugates. Okay, so all you're doing is just changing the sign and then multiplying. Okay, so let's say, for example, if we wanted to rationalize the denominator, of 1 over square root of 2 plus 1. Okay, so really you just multiply both by the conjugate. Okay, so you have 1 over square root of 2 plus 1. That's just going to equal 1 over square root of 2 plus 1 times square root of 2 minus 1 over square root of 2 minus 1. And then you just go ahead and FOIL that out. Okay, so you end up with 1 times, we'll leave that there for now, square root of 2 minus 1 over your first times your first. Square root of 2 times square root of 2 is just 2, but I'll go ahead and write it out. Square root of 2 times square root of 2. Your outer, square root of 2 times negative 1, which is negative square root of 2. Your inner, square root of 2 times positive 1, which is just positive square root of 2. And your last, 1 times negative 1, which is just negative 1. So as you can see, when you multiply by the conjugate, the two middle terms are always just going to disappear. They're going to cancel each other out. Okay. So you end up with 1 times square root of 2 minus 1 is just square root of 2 minus 1 over square root of 2 times square root of 2, square root of 2 squared, which is just 2, minus 1. Okay, so square root of 2 minus 1 over 1, which is just square root of 2 minus 1. All right, so any questions on that one? Okay. All right. There we go. Let's say for our next example, we wanted to rationalize the denominator of square root of x plus square root of 2 over square root of x minus square root of 2. Okay. So the first thing we're going to do is just multiply it by the conjugate of the denominator. So square root of x plus square root of 2 over square root of x minus square root of 2 is just going to equal square root of x plus square root of 2 over square root of x minus square root of 2 times the conjugate of your denominator, which is square root of x plus square root of 2 over square root of x plus square root of 2. Okay, and this time for both of them, you're actually going to perform the FOIL method. So you're going to have the FOIL method up here and the FOIL method down there. Okay, so for our numerator, square root of x times square root of x. You have your outer, square root of 2 times square root of x. And your inner, square root of 2 times square root of x. And your last, square root of 2 times square root of 2. All over, do the FOIL method again, square root of x times square root of x. You have your outer, square root of x times positive 2 square root of 2, or positive square root of 2. Your inner, negative square root of 2 times square root of x. And your last, negative times positive square root of 2. Negative square root of 2 times positive square root of 2. Okay, so you can see in your denominator, those two disappear. They're opposite, so they cancel each other out. Okay, so you have square root of x times square root of x, which is just equal to x. Square root of 2 square root of x plus square root of 2 square root of x is just 2 square root of 2 square root of x. Kind of like if you had y plus y, you just get 2y. Plus square root of 2 times square root of 2 is just 2. All over square root of x times square root of x is x. Square root of 2 times square root of 2 is just 2. All right, so any questions on that one? Okay. I'm going to do one more example. Oh, you want still writing? Oh, I'll wait a few seconds. All right. Okay, so let's say, for example, we wanted to this time rationalize the numerator of square root of x minus 3 over square root of x. Okay. Now you do the exact same thing that we did for rationalizing the denominator, but instead we get rid of any square roots in the numerator. So our goal is to remove any root symbols, or radical symbols. Yeah, clean that up. From the numerator. Okay, so whichever one you have to rationalize, that's where you're going to remove the root symbols from. But the approach is exactly the same. And that's going to cut off in like a minute and a half.